Welcome to the Taos Machine Translation and Moses tutorial. In this demo, I want to show you how to bulk translate a set of test sentences with an available Moses SMT system and then calculate the BLEU score for this test set. In the second part of the demo, I show you how to optimize the Moses SMT system for faster translation speed and reduced memory use. In the previous data cleaning and data tokenization demo, we already created a set of 100 test sentences that we can now bulk translate using the trained Moses SMT system. We're creating a folder called test to contain the output, and then filter down the translation model of the trained system with the script filter model given input.pl, specify an output directory for the revised data, specify the original MT system configuration and the test set, and for this small system this quickly filters down the model to only the data that is needed for the translation of this test set. The revised phrase table is only about 512 kilobytes large and the reordering table 2.5 megabytes compared to the original phrase table with a size of 9 megabytes and the reordering table of about 4 megabytes. So we can now use this revised translation model together with the language model, of course, to translate the test set. We're specifying the revised configuration and the test set, and we're outputting the results into a file called hansard.test.out.en. And this loads the filter model into memory and starts the bulk translation. After a couple of minutes, the bulk translation is finished, and we can have a look at the results. You can see the sentences are translated, and we can do a BLEU score evaluation using the multi-BLEU.perl file that is contained in Moses. We're specifying the reference translation of our test set, hansard.test.en, and compare this to the output, and we achieve a BLEU score of 30.06. However, reducing memory usage and speeding up loading time by filtering the translation model every time we want to do a bulk translation is not very convenient. It is also unrealistic in cases where we want to use the SMT system for online translations. What we can do instead is to binarize the model to enable on-demand loading. And for this we create a new model directory and use the process phrase table command to binarize the textual phrase table. After the phrase table is binarized, we also need to binarize the reordering table using the process lexical table command. And the result is again going into the binarized underscore model folder. Once the binarization is done, we need to adjust the MT system configuration to use the binarized model, and we do this by editing the configuration file. What you first need to do is to change the translation table type to 1, and then just change the folder name and correct the phrase table name for the binarized phrase table. And we need to do similar editing for the reordering table by adjusting the folder name and removing some of these additional characters in the name. And then we can use a new binarized translation model to translate our test sentence again. Ottawa est la capitale du Canada. And we make Moses use the new configuration. And you can see the translation is correct and the translation happened noticeably quicker. To speed up the MT system even more, we can switch from the IRST language model to the CanLM language model, which is included in Moses. For this, we first have to bring the language model data into a standard ARPA format, and the compile-lm command is used for that. And then we can build a binary language model out of this, which then can be used by CanLM. And again, we need to edit the configuration to use this revised language model. Need to change the language model type to 8 and just change the name of the language model to the binary one and save this configuration file, and then use it in the translation of our test sentences. And again, we get the same translation, just at a much faster speed. This is the end of the bulk translation and MT system optimization demo. For further presentations and demos in this tutorial, please go to the web address shown on this slide. Thanks for listening.